Hi guys. Today we'll do that the implementation of stack using queues and queues using stack. So share the screen. Yeah. So this is the question that is going to you implement stack using queue, right? So yeah, it is an important question, and um, so what you have to do in this implement stack using queue. You have to implement the stack all the operations such as push method of the stack, pop method, top method, empty method of the stack using the queues operation. So using queue, right? So as we know, the queue is an interface and it has subclasses, priority queue, array queue, and linked list. So we'll take the array queue. So first we will solve it. First I will tell the approach that how do we this, how do we implement this. So the implementation part is that we have to implement the stack using queue, right? So we'll do like this. Um, uh, this is the example has been given to you. So basically what we have to do is the push operation, right? In the push operation, what we have to do? In the push operation, the first step is that we will add x to q1. Okay, x will be some integer, right? We'll add x to there are q2, q1, and q2 to q. So first we will add x to q2, right? And then uh, we will add all the elements of q1, elements by elements to q2. And the third step will be we will swap q1, comma q2. We will do swapping, right? So these three steps we have to perform in the push operation. And in the pop operation, we have to do nothing, but we have to remove the top of the q1. We have to remove the top of the q1, and in the p and then pop and peak also we have to do the same only. So this is how we are going to implement the stack using two queue data structure. So let's do it. So how this can be implemented, just I want to explain more one thing that I think I want to explain more by the help of this uh, example. Let's say over here it is a Q1 and over here it is a Q2 and over here is a stack, right? So stack doesn't matter if suppose we suppose uh, my stack is there and the push operation is there, right? So in the push operation, what does we do? We push the element to Q1, we push the element to Q1 and we add all the elements from Q1 to Q2 and then we swap. So there is if there is nothing element from Q1, then nothing can be added, and then swapping it will come, one will come here and one will remove from here, one will remove from here, right? So again when we are going to adding two, right? So we first will add over here, then we will take all the elements from Q1 to Q2, so one we will add over here and remove from here, and then we will swap both the elements. So if we will swap both the elements, so there will be 2 1. And then if it comes right like top, what will be the top? So q2 will be the top. In stack what does happen? 1 and 2, you can see in q also 2 will be out, and in stack 2 will be out. So this way we are going the correct way. And after popping it, 2 will be pop out, and here also 2 will be pop out. So this way we implement the stack using q data structure. And let's do this. Let's code for this. So yeah, so q of integer, right? Uh, q1 is equal to new array dq, and also integer. Yeah, we have created one queue. So in the similar way, we have to create the another queue also. Yeah, we can create over here, or we can create over in the constructor also. Doesn't matter. So in the push operation, what I was telling to you that first we will add element to Q2. So what we'll do, we'll Q2 dot offer. In Java it is offer. Q2 dot offer of x, and Q2 dot offer dot x, we add element to the Q2. And the next thing what we are doing, we are taking all the elements of Q1, and uh, we are pushing into the Q2, right? So until Q1 dot empty, until Q1 dot is empty, until Q1 dot is empty, we will push all the elements into the Q2. So Q2 dot offer, and inside this Q1 dot pool, right? So we'll add all the elements from Q1 to Q2, and then on swapping Q1 and Q2 means we'll add again all the elements from uh, Q2 to Q1, right? So for adding all the elements from Q2 to Q1, it will be like this until Q2 is not empty. We'll add in Q1, uh, Q2. Yeah, the pop operation is over. And coming to the peak of pop operation. So in pop operation, we will return the top of the Q1, Q1 dot pool, right? And the top operation, we will return Q1 dot peak, and we'll check if it is empty or not. Okay, return Q1 dot empty ty. Uh, is empty. So let's check this. Okay, some error is coming. Uh, yeah, over here it is Q1 dot pool is written. So it is a method, and it should have a bracket in. It is also a method, so it should also have a bracket. So let's run it. Yeah, it is accepted, and let's see on submitting it. Yeah, it is submitted. Okay. So the the follow-up question is that can you implement the stack using a single queue? So let's do this. Uh, Using a single queue, there is another algorithm for using a single queue. What is the algorithm? First, I will discuss that. Uh, let me take a pen. So in the push operation, if we want to push x, so first step is that if we'll do q1 dot push x, okay, we'll push the element into the queue. We'll push the element into the queue, and then um, what we'll do, uh, suppose there is element, suppose that 1 2 3 4. So uh, we will take the top n minus 1 elements from this queue, and again we will add uh, and again we will add again. Uh, suppose let me take a eraser first. Yeah, suppose we are having in queue that 1 2 3, right? And if we want to add 4 into it, right? If we want to add 4 into it, so 4 is added into it. But after adding 4, what we are going, we are taking all these three elements and we are again pushing into the queue. And we are again pushing into the queue. Okay. We are again pushing into the queue. So it will be 4, 1, 2, 3. So this will be the pushing operation. So for what happens in the stack? What happens in the stack? What happens in the stack, right? If you want to push 1, 2, 3, 4, if you want to push 1, 2, 3, 4 in the stack, so it will in like this order: 1, 2, 3, 4, right? So if you want to means pop, or if you want to do a pop operation on this stack, so we will remove the first one, and in the queue also we will remove the first one, right? Push operation is like this, and if you want peak, we will take a peak from here, and we also can take a push peak from queue over here. So like this way, the single queue is implemented. Let's code it. Uh, we can remove one queue, and in the push, what we are doing, we are first pushing that element into the queue, and then what we are doing, we are what we are doing uh, until the size. What we are doing over here, we are running a loop till n minus one. So int I equal to 0, I less than q1 dot size. Hmm. I less than q1 dot size minus 1 and I plus 1. So we are popping all the elements from Q1 and we are again adding it to the queue. So it will be like Q1 dot offer and Q1 dot you know uh, Q1 dot pool. Yeah, we'll remove it and we'll add it element by element. Yeah, this way the operation is done. And in pop it is Q1 dot pool. In top it is Q1 dot peak. Yeah, everything is fine. So says it is accepted, and like this way the using single queue is implemented. And the next question is that if we want to implement queue using stack data structure, so I've already coded said this is a stack 2 have taken to that stack data structure, and the push operation we are simply pushing into it the stack s1, and in the pop uh, what we are doing, uh, we are emptying the we are pushing all the elements into the stack and stack 2, and we will do s2 dot pop, and then again we will push all the elements into the back into the s1. So like this pop operation is done, and also the peak operation is also done in the similar way. What is done over here, let me tell you over here that suppose that if we want if we want to implement 1, 2, 3, 4 in the you know in the queue, if using stack, right? So we will take two stack s1 and s2, and s1 and s2, and it is also queue. If we push this 1, 2, 3, 4, so it will be 1, 2, 3, 4 in here, and if you do it, it will be 1, 2, 3, 4. So if you want to do a pop operation, what will be the outcome of this view? This will be 1, and what will be the outcome from the s1? It will be 4. So it is different, right? So make it same. What we'll do, we will make all the elements from s1 to s2. So 4, 3, 2, 1, and then we will pop it. So see, same elements are there, and then after popping it, 2, 3, 4 are remaining. Then we will push again back 2, 3, 4 to s1, right? So the name x1 will be 2, 3, 4. So like this, this code works. So you can see over here. Yeah. So you can see the code. Yeah. So that's all about it. Thank you.